Well, welcome back. We are starting Chapter 7 in this lesson on ratios and proportions. And our goal for this lesson is to be able to write ratios to solve proportions. A ratio is just a comparison of two quantities that uses division. It's just one number divided by another number. And there's three different ways that we can write ratios. We can write them as a fraction, a over b. We can use a colon symbol, a colon b, or we can use one number and then the word to, T-O, to b, so a to b. A and b are usually expressed in the same unit, so that there's really no units involved with ratios. So here's an example with bonsai trees. It says the bonsai bald cypress tree is a small version of a full-size tree. A bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? Well, we need to convert these units to be the same. So the smaller one is 15 inches, but the larger one is 118 feet. So in order to convert that, we need to convert our feet to inches using our conversion of 1 foot is 12 inches, lining up our units so they cancel, and we get 1,416 inches is how tall the Senator is. So now that we have the same units, we can compare those together. And we have 15 inches to 118 feet, which is 1,416 inches. And then if we divide both of those by 3, we get a ratio of 5 to 472. And again, there are no units on our ratios because the units are the same and they cancel. Here's one for you to try. Go ahead and pause the video and see if you can come up with the answer on your own. I'll give you the answer when you get back. Alright, I hope you had a chance to try that. This one says a bonsai tree is 18 inches wide, stands 2 feet tall. What is the ratio of the width of the bonsai to its height? So first of all, the bonsai is 18 inches, the other one is 2 feet. And then we want to go ahead and convert the 2 feet to inches, and that's multiplying by 12. So we have 18 inches to 24 inches. And we can simplify this by dividing by 6 on both the numerator and denominator. So we have 18 to 24 becomes 3 to 6. And our units then would cancel, so we would just have the ratio of 3 to 4. Dividing a quantity into a given ratio. We have members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio, number of tulip pots to the number of daffodil pots, will be 2 to 3. How many pots of each type of flower should they buy? Well, we need to introduce a variable, and usually we use x. So we're going to let 2x be the number of tulip pots, and 3x be the number of daffodil pots. And then we're going to go ahead and set up an equation to solve. So if we took 2x plus 3x equals 120, the total number of pots, and solve that for x, we get 24. So now if we go back and double the 24, that'll give us the number of tulip pots, and multiply it by 3, and that'll give us the number of daffodil pots. So you can see that we would need, the band members should buy 48 tulip pots and 72 daffodil pots. Again, here's one for you to try. Go ahead and pause the video, and we'll work through it together when you get back. Alright, it says the measures of two supplementary angles are in the ratio of 1 to 4. What are the measures of the angles? Well, we're going to set up that variable, 1x plus 4x. Supplementary means they add to 180. So adding those together, we get 5x equals 180, or x is equal to 36. So to find the measures of the angles, we have to actually substitute in. So one of them was the ratio of 1x, so one angle is 36 degrees. But then the other one we need to actually multiply by 4. Somewhere over here I did that. Let's see if I can find it. Whoops. So 4 times x, 4 times 36, gives us the second angle of 144 degrees, and you can see that if you add those together you would get 180. An extended ratio compares 3 or more numbers. So here's an example with apples, oranges, and bananas that are in the ratio of 2 to 3 to 5. And you can see as we move down the table, just multiplying our ratio in the first row by 2 gives us the second row. Multiplying by 3 gives us the third row. Multiplying by 4 gives us the fourth row. But they still stay in that same ratio of 2 to 3 to 5. So this problem we're going to use the extended ratio to find the perimeter of a triangle. So the lengths of the sides of a triangle are in the ratio 3 to 5 to 6. The perimeter is 98 inches. What's the length of the longest side? Well, the best thing to do, first of all, is to go ahead and sketch a triangle, which I have for you in your notes, and use the extended ratio to label the sides with the expressions, and we want to solve then for x. So first of all, we need to go ahead and write our expression, 3x plus 5x plus 6x equals the perimeter of 98. Adding our like terms together, we get 14x equals 98, and dividing by 14 gives us x equals 7. So the longest side is 6x, so we would need to multiply the 7 by 6 to give us 42 inches. Again, here's another one for you to try. Pause the video and we'll work through it together when you get back. Alright, so let's take a look at this one. So this one, we have the lengths of the sides of a triangle are in the extended ratio 4 to 7 to 9. The perimeter is 60. What are the lengths of the sides? So here's your equation. Adding like terms, we get 20x is equal to 60, and x is equal to 3. So now we have to plug that back in. 4 times 3 gives us 12. 7 times 3 gives us 21. And 9 times 3 is 27. If you were to add those together, you would get the perimeter of 60 that we said in the problem. An equation that states that two ratios are equal is called a proportion. I like to teach students that a proportion is just two fractions that are equal, because more often than not, you will see them set up as fractions. So the terminology that you need to be aware of is the two outside numbers. Those two outside numbers are called the extremes. The two inside ones are called the means, and that's when you write them as a colon. When you write them as fractions, it's the top and bottom numbers that are along the diagonal this way. Those are called the extremes. The ones in blue are called the means. And the means are equal to the extremes. So here are two examples that we're going to work through. What's the solution? Well, we do what's called cross multiplying, or the cross product. So we get 4 times 6 is equal to 5 times x. Dividing by 5, we end up with 5x is 24, or x is equal to 4.8. Over on the right hand side, we get 3 times the quantity y plus 4 equals 9y. Distributing our 3 through the parentheses and then subtracting 3y from both sides, we end up with 12 is equal to 6y, or y is equal to 2. So here are 3 different properties of equality that we can use with proportions. The first property says if we have our proportion set up, we can also write that where we actually take the reciprocal of each of those fractions or each of those ratios. So if we flip both of them over, we get b over a is equal to d over c. So that's the reciprocal. We can do that. The second property says, if you take a look at that one, we just switched b and c. Okay, so we switched the means. So we're allowed to do that in proportions. If we just switch the means, it still works out. And the third property says that what we can do is we can add the denominator of each expression to the numerator, and it still works out. So in the red one, you can see we have b. If we add that to its numerator, add d to the numerator, then we have another property that we can use to solve proportions. So here we go. It says in the diagram, x is to 6 as y is to 7. What ratio completes the equivalent proportion x is to y equals what over what? And justify your answer. So first of all, we'll write the original proportion. X is to 6 as y is to 7. But then we want it to be x is to y. So what we did is we switched the means here, and that was property number 2. Allowed us to do that. Here are 2 problems for you to try. Please go ahead and solve these and write which of those three properties you're using to solve, and I'll give you the answers when you come back. All right, on the left side for letter A, we have 6 over x equals what over what, and our original says y over 7. So how did this differ from the original? Well, the original was x over 6. So what we actually did was we used the reciprocal property, which is property number 1. On the right-hand side, how does this one differ from the original? Well, on the right-hand side, it looks like 7 was added to the numerator. So we need to add the denominator on the left as well. So our proportion would look like this, and that was property number 3. Here is your lesson check. Please complete these problems and bring them to class next time.